Hi, this is a CBSE 12th Physics 3-mark question. The question reads, a ray of light PQ enters an isosceles right-angle triangle ABC of refractive index 1.5. We have to trace the path of the ray through the prism, and then if the refractive index is 1.4, then we have to again see what will be the path of the ray. So the key concepts which will be used is sine C is 1 by n, and we should also know the Snell's law that n is equal to sine I by sine R. So what is given to you is a right-angled triangle ABC, right-angled at A, and the incident ray is PQ, and refractive index is given 1.5. So now first we can see that the ray is first hitting the BC surface, and it is hitting normally. So angle of incidence is 0. So by Snell's law, when angle of incidence is 0, R is also 0. That is why the ray goes straight undeviated and hits the surface AB at Q. Now at Q, it is hitting, making an angle 45 degree with the surface AB. So since the dotted line shown here is normal to AB, so this angle will also be 45 degree, and this is the angle of incidence on this surface. Incident ray, angle between the incident ray and the normal, this is the angle of incidence, that is 45 degree on surface AB. Now we have to see that from here, the ray is moving from denser to rarer medium, whether it will be total internally reflected or refracted. For that, we need to find out what is the critical angle. So to find the critical angle, we'll use the formula sine C is 1 by n, or 1 by 1.5, or 1 by 1.5 is 0.6667. So C value is sine inverse of 0.6667, and this value is 41.8 degree. So here we see that the angle of incidence is greater than the critical angle. So when angle of incidence is greater than the critical angle, it will be total internally reflected. Now when it will be reflected, the angle of reflection will also be 45 degree. And when the angle of incidence will be 45 degree, the reflected ray will go parallel to the base BC. So this angle will be 45 degree angle of reflection. It is total internally reflected inside the medium. Now when this is 45 degree, this is also 45 degree because that's the normal. Now when this is 45 degree, this will also be 45 degree. And suppose this ray meets the surface AC at point T. At point T, if I draw a normal, then this angle will also be 45 degree. So the angle of incidence on the surface AC will also be, at the surface AC also, angle of incidence will be 45 degree, and the ray is moving from denser to rarer medium, and again the condition of total internal reflection. So it will be internally reflected, and it will be reflected at 45 degree. So it will go parallel to PQ. Will go parallel to PQ. Suppose I name it as S. So TS will be parallel to PQ. Here again, it will fall normal. So angle of incidence is 0, angle of refraction will be 0, and it will go undeviated. So the path of the ray in this case will be QT, which will be parallel to BC, and TS, which is parallel to PQ. So 2 times total internal reflection is happening on surface BA and AC. And on BC, refraction is happening and it is going undeviated. So this is the path of the ray in the first case. Now, second case, the refractive index is changed to 1.4. So let us see what will be the critical angle here. So the critical angle in this case will be sin C is 1 by 1.4, or this is 0.7143, or the critical angle here will be sine inverse 0.7143, or the value is 45.5 degree. So here we see that in the second case, we know that our angle of incidence is 45 degree, but and critical angle is 45.5 degree. That is, angle of incidence is less than the critical angle. So since it's less than the critical angle, it will not be total internally reflected, but it will be refracted. And refracted means it will move out of the prism. And when it is moving out of the prism, it is moving from denser to rarer medium. So denser to rarer medium, it will move away from the normal. So when it will move away from the normal, it will take up a path away, that is instead of going straight, it will go away from the normal. Instead of going straight, it will go away from the normal. So it will take up a path away from the normal. It will not go straight, but will go away from the normal, and angle of refraction will be more than the angle of incidence. So hope the problem is clear to you. If you want to see my further videos, please subscribe my channel and also share with your friends. Thank you.